Okay, we're back. And we're back with angles and triangles. Some of you have been waiting for this because this is where you use your protractors to measure the angles and triangles. Okay, so facts about angles and triangles. Okay, we've got some of the same words that we've already used. Congruent means that the angles are just the same size, same shape. A right angle has a square corner so that you can put the square of the paper into the corner. Okay, this one has a circular type mark because it does not make a square corner. Okay, but if it's a square corner, it's 90 degrees and we call that a right angle. Okay, with a square corner. And then an acute, this is a cute little, cute. It's acute. Acute means it's smaller than the 90 degrees. Okay, so this is 90 degrees. And when they say 90 degrees, they're talking about this. Okay, so you would normally put in this hole right here, you would put the corner. What's the corner called again? A vertex. I wish I could make this bigger. Let me draw it bigger on this board here so you can see what I'm talking about. Okay, so here's an angle, and I didn't make it with a ruler, so it's not probably perfectly straight like a right angle would be. Okay, and here's my protractor. You line up the very corner of the vertex right there in the center, and this line of the angle should be straight with that. Let me make it smaller because you can't even see the top of my protractor. Okay, so it should be exactly, it's kind of hard to do it with something here. That should be straight on this edge of this ruler thingy here. And then you take and you follow up the swing arm, and this is a curvy line, so it's not very good, and it will tell you how many degrees it is up here. If it was perfectly straight, which it's not, then it would go right up to 90, because 90 is exactly half, right? This is a half circle. A half of a circle is a 180 degrees. A full circle, if we were to take another protractor and put it on the other side, making a circle, can't see that too well, then that would be 180 plus 180, which is 360. So a circle makes 360 degrees. A 180 is a half of a circle. Okay? So sometimes you hear somebody say he did a 180. That means he completely turned around and went the other way. Okay? Went half of a circle. So if you guys were here, we would do this, but you're not here. But you can still do it. Stand up. Okay? Face me. And then if you turn half of a circle, face the opposite way, now you've turned 180 degrees. Now keep turning, go around all the way, and it's 360 degrees. Okay, so one whole circle, you turn 360. All the way backwards is a 180. So if someone has a 180, it means they changed their mind or they completely went the opposite direction. Then half of 180, what would half of 180 be? 90. Okay, so just like a clock, we can make this into fourths, right? So it would be 90, 90, 90, 90. 4 90s makes 360, right? So if you were to make your angles this way, a fourth of the circle is 90, a fourth of the circle is 90, 90, 90. You see? Okay, so that's what this is. A right angle is a fourth of a circle, and it means it's straight up and down so that it makes a corner. Okay? And like I said, if I had done that, drawn one perfectly, you can't see that too terribly well, but there's a 90 right there. If you have your protractors, you can get them out and look. You could pause me, get them out and look. They should be in your bags. I found most of them. Most of them were in the drawer like they were supposed to be, but then some of you guys left them in your desk, and I tried to find them, but some of yours I could not find. So either you don't have them, didn't have them to begin with, or you've hidden them from me somewhere. Okay? So I tried. But anyway, if you look at the middle here, you'll also notice I just don't like the way that, let's see if we can see this other one better. I just don't like the way, ooh, that's even worse. What if I put a dark, something dark behind it? Does that help because they're white? Yeah, there we go. Ah, there we go. Okay, so if it's a straight angle, straight up, on this protractor, you have to actually put the line in here, okay? On this one though, you put the line next to it. I saw Emma has some like this, kind of, they look like this. So then your line is right next to the swing arm, and on this swing arm it has a hole in the middle, so you actually put the line in the hole. A lot of you have this kind if you bought it from me, because that's the kind I had at the beginning of the year for you guys to buy, okay? But if you had an angle that went like this, that would be 90 degrees. Okay, and like I told you, we're not even supposed to have to do this with a protractor. I just think it's kind of fun, and next year you'll use it some more. So if you want to practice measuring them, great. It also helps you to understand what I'm talking about when I say that a right angle is 90 degrees, and then an acute angle, acute, is less than 90. So here's a 90, but if you made an angle that was less than 90, then that would be an acute angle, and I say it that way so you think tiny. And the opposite way would be obtuse. I just try to say it to make it look, see, here's a 90-degree angle right here, and one that's bigger than 90 degrees is obtuse. Okay, it's supposed to sound like it's a big one. So 90 degrees is a right angle, smaller, acute, larger than 90, obtuse. And then a straight angle is just straight across there, and that one's the 180 degrees, okay? Then those are angles, and then we also have triangles. The difference between angle and triangle is the word tri, and tri, if you have a tricycle, it means 3. So triangles, see, here's an angle, here's an angle, and here's an angle. Okay, it has 3 angles that connect together and make a triangle. So we have the same words here. A right triangle has one right angle. You can't do 3 right angles or it ends up being a square or a rectangle. Isosceles triangle. Wait a minute, I skipped one. Well, they have a right, okay, no I didn't. Okay, right triangle, still have that word, but then they have isosceles triangles that have 2 congruent sides. So that means this angle measures the same as this angle, even though it's backwards. Let me see if I can show you what I mean. These are just so small. Okay, so I can't really show you on that. Let me try blowing it up and just showing you on the board. I don't know. Let me try to trace this perfectly. You see what I'm doing? And then there's an angle right here. Okay, let's see if we can measure these so that you can actually see it. It's about the best we're going to get. Okay, so I'm going to put the vertex of this angle right here, and I'm going to line that up with 0. You might notice there's 2 different sets of numbers here. There's a 0, and then there's 180. And then 0, 10, 20, 30, 40, 50, 60, 70. Or this one's going backwards, 180, 170, 160, 150, 140. You come all the way, 90's at the top. 90 is the same on both. Okay? And then it goes 80, 70, 60, or 100, 110, 120. Back over here you have 0 and 182. That's because you can measure angles that go that way or angles that go this way. Okay, right now the angle's turning to the right, so you line it up right here on the 0 line. Here's the 0. And then you follow it up with your arm, swing arm, to the number. Okay, so this is right at 110. So remember that for a second, 110. Okay, that angle right here measures 110. Okay, now for the other angle, we have to put the vertex here again in the circle, and the bottom of the line has to be straight again right here, and then I'm going to swing the arm over to line it up. This one you have to line it up on the edge, and I must not have made this perfectly straight because it should be right at 110. So see, now I'm using this side of the circle. The angle's going this way. So we would make it like this. So the angle goes this way. This angle goes this way. Okay? So the best thing I told kids to do is to start, you know, this is 0. And then follow the line that has the 0. Okay? The 0 up to here. Oops, that's not right. That's 70. Did I do it wrong on the other side? What did I do? I looked at the wrong number, didn't I? See, even I'm as guilty at doing that. Yep, I looked at the wrong number. Which, duh, 110 is more than 90. That means it would be back this way. Okay, so I did it myself. I looked at the wrong number. Over here is 0 starts here. 10, 20, 30, 40, 50, 60, 70. Okay, so both of those were 70. 70 degrees, 70 degrees. So if it's an isosceles triangle, it means it has two congruent triangles, or angles. This other angle up here was a different one, and I can tell you what it was because all triangles, all of them, always measure up to 180 degrees. Isn't that weird that that works? It doesn't matter. You can draw triangles all day long, and you measure all 3 angles. You have to make them nice and straight if you're going to measure them. But every triangle you can make is going to end up, when you add all the angles together, will end up 180. Okay? So if we know that on this isosceles triangle that these two are 70, 70 and 70 makes 140, right? So how many more degrees do we need to get to 180? 40. Well, let's see if I can measure that. Let's see here. I don't know if I can do this or not. Yeah, that's off. I'm just trying to finish out that triangle. So definitely not a perfect system here, but we have to turn this one upside down and put one of them on the line. Okay, the corner and one of them on the line, on the 0 line. And then you swing your arm down to here. Oh, it did work pretty well. Just a little bit off because my lines are not totally straight, but there's the 40 right there. Okay, so 70 plus 70 plus 40 equals 180. Every triangle will equal 180. Okay, every single triangle. It's kind of cool. So back to the triangles. If it's a right triangle, it has one right angle. We couldn't do, like I said, we couldn't do 4 right angles or 2 right angles because that equals a different shape. See, there's one right angle and there's those 2 are not right angles. They make a right triangle. Okay, then the isosceles triangle has 2 congruent sides. Remember the whiskers? The whiskers mean congruent. And then the equilateral triangle, all 3 angles have to be the same. And that's the most pleasing to me, the most pleasing triangle, because it's got every single angle is the same. So what angle, would be the degrees of the angle if it's 180 and they're all 3 the same? What would 180 be divided by 3? 60. So this is a 60-degree angle, this is a 60-degree angle, this is a 60-degree angle. So they all equal 180, okay? So they're going to ask us some questions now about that. So get your paper ready. It says name the type of triangle. I'm going to make this kind of small just so we can see them all. You guys have your paper. Okay. This one has 2 that are the same, 2 congruent sides. That makes it an isosceles. Oh boy. SC? Yeah, SCELES. Isosceles triangle. This one has the square. That square means what? It means that it's a 90 degree or corner angle. So any triangle that has a 90 degree angle is a right triangle. So this is actually right triangle, isosceles triangle, and this one congruent on all three sides means it's an equilateral triangle. Okay? Then down here it says to find the third measure. Now you could go ahead and use your compasses, but you don't have to, because we know that, I'm going to get rid of the green one there, we know that all of them measure 180, so you don't even need your compass. That's what I mean. In the zebras book, they had to use their compass to measure them, and we are going to do a page like that just so you can have fun with measuring them, but you don't have to, because we know that 180 degrees makes a whole triangle. So we've got these two numbers, 90 and 60, equals what? If you add them together, that equals 150. So what do you need to add to 150 to come out to 180? 30. So this one is 30 degrees. And you use a little degree sign just like temperature, but they obviously don't mean the same thing, do they? It has nothing to do with temperature. Okay, this one has a 90 degree angle. It's a right triangle. And 45. So what's 90 and 45? Or you can think of this. These two both have to be half of 90, because 90 is half of 180, right? It's 90 plus 90. Okay, so here's 190. Here's 45. 90 minus 45 is 45. So every right triangle is going to be 90, 45, 45. That's the way it has to work that way to be a right triangle. Okay, and then this one equal, 60, 60, 60. 60 times 3 is 180, but you also know that these are all congruent to each other, the same angles, so they're all 60s. Okay, then it says to use the given information to name the type of triangle. So if the angles are 30, 60, and 90, you see that it has a 90 there, which makes it a right triangle. I'm just going to write the word, well, and we'll do that for sake of time. Sides are 3, 3, and 3. So if all three sides are the same, it's a equilateral triangle. Okay, sides are 4, 5, and 4. Okay, so there's two congruent ones. They're the same size. That makes it an isosceles triangle. Two of the three angles are 50 and 40. So 50 plus 40 makes 90. How much more do you need to make 180? Another 90, and a 90 degree angle is a right angle, so that makes this a right triangle because it has to have a 90 degree angle. Okay? Angles are 60, 60, and 60. Look at the triangle in exercise, whatever. We don't need to look at that. All three sides are the same. We're back up here again. It's a, whoops. Well, the answer's over there. Equilateral, you guys can write it. Equilateral, and then 9, 9, and 9, also equilateral. I wonder why they put two of exactly the same. Did I miss something here? No, both of those are equilateral. Okay, then these geometry pages are easy for you guys because we do most of them ourselves. Okay, name the geometric figures. This was what we learned 2 days ago. I'm not going to tell you what they are. You can either try to remember or you can look on your paper because you don't turn those in now. You've taken pictures of them. Hopefully you're keeping them. Or guess what? In your yellow math folder, go under geometry and you'll be able to find all of these as well if you can't remember. Okay? And then the questions about the rectangle. You know what? I answered these with you the other day. So I'm going to let you guys go back to that page and try to figure this out. Okay? Otherwise, you don't have much to do at all. I will help you with the true and false. Even though this is what we did the other day. I will help you with that. And then you just have 2 story problems and 4 problems at the bottom. And then I want you to go back and do section 5 on your own and 4. Okay, so what is a simple closed figure formed by line segments? That is called a polygon. Remember that word? Sounds like polywog. Makes me think of spring. What has an endpoint, one endpoint, but continues indefinitely on the other side? That is a ray. Also, you guys can kind of this and, do you guys know this? If you start the word, all of these are us mostly, except for these two. If it has a word and, what does that mean? It means the next word will start with a vowel, right? So this word's going to start with a vowel. And what is made up of two rays with a common endpoint? We did these today. An angle, and not angel, angle. Okay? A what is a polygon having 6 sides? 6 hex. Remember? Hexagon. Okay? And I'm going to start with a vowel again. And something triangle is a triangle having 3 congruent sides. Equilateral. Good. I heard somebody say that. Okay, and then letter F, a what is a quadrilateral having opposite sides that are parallel? That is, let's see, opposite sides that are parallel. Is that the parallelogram or the rectangle? I may have to look that up myself. And I don't have my book here, so you guys will have to look it up. I think opposite sides that are parallel, I think that's a rectangle because, well, I think it could be either one, a rectangle or a parallelogram. I could be wrong. I'll have to get back with you on that. I don't have my book here. Okay, it's one of those, but because both of those have opposite sides that are parallel. Remember, here's a rectangle. Those 2 lines are parallel. These 2 lines are parallel. And in a parallelogram, those 2 are parallel and these 2 are parallel. So I really think it could be either one. Okay? And the last one, a blank is represented by a dot. Remember what the dot is in geometry? It's a point. Good job. Okay, and then tomorrow you're taking your test. It won't have geometry on it, I don't think, because we just started geometry. It'll just be a review of what we've been learning. And then I'll see you Thursday. Have a fun week.